Hello my dear students, welcome back to NEET World. So today we will be discussing SAQ questions from these D and F block elements and along with that coordination complexes. Okay, so there will be one 4 marks question from coordination compounds right now. So that we will be discussing here in this session. So just look at here. So this is our C60 material. This is designed for all the IPE students, for both AP and Telangana students. So this material is highly helpful for all the IPE students of AP and Telangana, second year students, as well as we have separate material for first year students also. Now you can access these materials for free of cost in our MedWorld app. So just download MedWorld app from Play Store. Okay, just download this MedWorld app from Play Store and just say hi in the chat box. Okay, so that our team will share you these links. I mean these like soft copies of these materials. Okay, now you can access all these soft copies. Not only chemistry, you can get it for physics, mathematics if you are an MPC student along with the chemistry, and if you are a BPC students, then you can get like physics, chemistry along with your bio subjects. Okay, biology. Okay, that's it. Now you can use these materials and you can make your preparation. And one more thing guys, here we are giving all the free live content. I mean we are discussing each and every question that is designed in this material for your IPE preparation by looking the past year papers in our NEET World channel. So in our NEET World YouTube channel, we are explaining each and every question very clearly for all the subjects in a regular basis in our NEET World channel. So now what to do? Just first download the materials from this MedWorld app, then listen to our classes in this NEET World YouTube channel. Okay, yes. So if you check the playlist of this NEET World YouTube channel, you will be having like lot of sessions that are conducted for each and every chapter from all the subjects. Okay, right. You can use all these free live sessions and you can make your preparation very effective and you can gain maximum marks in your IPE exam. Okay, so now in this session we will be discussing SAQs, that means 4 marks question for your class 12th IPE. Okay, and that is particularly from these D and F block elements and coordination compounds. So from where it is D and F block and coordination compounds. Okay, now let us understand the questions that are asking from this channel. This chapter. First of all, look at here, explains Werner theory of coordination compounds. Okay, so this is one of the most frequently asked question, repeatedly asked. Now you can check previous year papers. Definitely there will be questions from this like whatever we are mentioning here. Say explain the terms ligand, coordination number, coordination entity. What do we mean by central atom, homoleptic and heteroleptic complexes? These are the questions they are asking. Okay, right. Now, right. So these are the other questions they are asking. Now let us start our discussion with this first question. Like it is mentioned about the basic terminology that are using in coordination compounds. Okay, explain the following terms. Ligand, what do we mean by ligand? And the next coordination number, coordination entity, and central atom or ion in this coordination complex. So these are the terms they are asking in the exam. So now it is very easy. Look at to this discussion, then you will definitely answer this kind of questions in your exam. Okay, first of all let us understand the top like concept involved here, then we will look into this like terms here. So first of all, in metal complexes, it means like organic like organometallic compounds, or I can say here coordination compounds here will be having indication of a square bracket. In this square bracket there will be one metal atom like this. Okay, around this metal atom there will be some anionic or electron density containing species, we can say them as ligands. Okay, let us say there are 6 ligands. How many ligands are there along with the metal? 6. Okay, so now what I am saying, there is a central atom, that is metal atom here. Okay, around this metal atom ligands are surrounded like this. Okay, with some proper orientation, with proper geometry, ligands will be surrounding the metal atom like this. Okay, so now whatever I am representing here, so this is nothing but if you observe, you will get a square with above one ligand and below one ligand. So this is called octahedral geometry. Like this, in the metal complexes, metal atom will be at the center, around we have ligands. Okay, so what I am saying, ligands. So what do we mean by ligands? Generally we know metals are electropositive, it means there will be some positive nature on it right now. That is what we are calling it as oxidation state of this metal. right now. So now if there is M plus 2 on this metal, the oxidation state of metal is plus 2, like this. See guys, I will be explaining each and every time very clearly, but before that you understand what I am discussing here, because this is a basic fundamental thing you need to know before understanding this. Okay, look at here. So if there is any charge on the metal like this, you can say that as a oxidation state of the metal. Okay, so here I am writing M plus N here, so it means the oxidation state of this metal is N. Okay, like this you need to get the oxidation states first. Okay, since metals are electropositive, there will be positive charge, positive oxidation state on the metal. Okay, now what happens is there are some ligands. Okay, ligands means those are something like they have more electron density on it. For example, if you see ammonia, there is one non-bonding electron pair. See, this is lone pair electrons and ammonia, na? So this can act as a ligand. This can act as a ligand. Similarly, if I write chloride ion, what I am writing chloride ion. See, here also negatively charged electrons are there that can be given to the metal. Okay, so like this, what is happening, since metal has transition metals, generally if you consider, there will be vacant d orbital. What they have? Vacant d orbital and with positive charge. And now our ligands will be having more electron density with negative charge or non-bonding electrons on it. So that electrons are given into this metal orbitals. What they will be? So that will be given into the metal empty orbital, like this. So when they are giving like this, now how they are? Ligand is donating pair of electrons and metal is accepting pair of electrons now. So you can consider metal as Lewis acid. What I am saying? Lewis acid. Okay, and our ligand is donating pair of electron now. You can say this as a Lewis base. Like this you can understand with the basic terms first. Okay, so now look at here. So ligand, it can be an ion or molecule attached to the central atom in the coordination sphere is called ligands. So what are the ligands? See, the square bracket indicates coordination sphere. In this coordination sphere, there will be central atom metal. Okay, around we have ligands like this. Okay, now what do these ligands do here? So they will donate pair of electrons to the metal. Okay, like this. Okay, so now 6 ligands are there. These 6 ligands donate pair of electrons to this metal and they will make a proper arrangement around this metal. Okay, so if there are 6 ligands, you will get octahedral geometry. It means the geometry, the structure will be look like a octahedral. Okay, if there is only 4 ligands in this coordination sphere, then you are going to get a geometry like structure of that particular complex as tetrahedral or square planar. Okay, so these are the basic things you need to understand first. Look at here. Next, ligand means what I told you. Ligand can be a molecule or an ion which donate pair of electrons to central metal atom. Okay, see, ion or molecule which attach to the central atom in the coordination sphere is called ligands. What is ligands? The ion or molecule which donate pair of electrons to central metal atom in the coordination sphere is called ligand. That's it. Next, what are the examples here I have given? Chloride ion, then next ammonia, and the next water, the next ethylene diamine. So all these are some examples for ligands. Okay, right. I hope this is clear, right? The next term, if you observe here, what they are saying, the next term here, coordination number. What do we mean by coordination number here? See, how many ligands are around this metal atom? There are 6 ligands now. So that is called the coordination number of this complex. So what do we mean by coordination number? The number of coordinate covalent bonds formed between the central atom and ligand. See, how many ligands are there? 6 ligands are there here. So each ligand is making one coordinate covalent bond like this. So how many coordinate covalent bonds you are seeing? 6 now. Therefore coordination number of this metal in the complex is 6. Okay, you just simply remember like this. Number of bonds made by ligands in the coordination sphere with the metal. Okay, so what I am saying, number of bonds made by ligands with this metal atom in this coordination sphere. The number of coordinate covalent bonds formed between central atom and ligand is called coordination number. For example, here how many ligands I am representing? 6. All these 6 are monodentate ligand. Therefore, like coordination number of this complex is 6. So now look at here. I have mentioned platinum tetracoordinated complex. It means how many chlorides are there here? 4 now. So now what is the coordination number of this metal ion in this complex? It will be 4 because there are 4 ligands. Now similarly, if you observe here, there are ammonia ligands. How many are there? 6 are there now in the complex with cobalt. Therefore, coordination number of this complex is a 6. How many ligands are there? 6 now, 6 monodentate ligands only. So like this you can write. Now if you want to get one simple formula for finding coordination number, just use this formula. Use this formula. Coordination number equals to 1 into number of monodentate ligands. What I am saying, number of monodentate ligands, okay, plus 2 into number of bidentate ligands, like that you can write. If it is a tridentate, 3 into number of tridentate ligands. So what do we mean by this dentation here, bidentate, here monodentate? It means there are some ligands. If you observe here, chloride ion is there, here ammonia is there. So they will make only one bond with the metal. Okay. Now that ligand will making only one donating side, like ligand is having only one donor side to the metal. Okay. But there are some ligands which are having more than one dentating side. For example, ene I am writing, ethylene diamine, CH2. Here if you observe there is NH2 group here and one more NH2 group here. Okay. So now using this lone pair electrons of both nitrogen atom, that will be binding to this metal like this. So how many dentations are there? How many ligating sites are there? 2 now. So you can say this as a bidentate ligand. What you can call? Bidentate ligand. So like that, if there is one bidentate ligand, how many bonds it is making? 2 bonds now. That's why the coordination number with respect to this ligand with the metal will be 2. That's why I am writing coordination number is equals to 1 into number of monodentate ligands. If monodentate ligand, it will make only one bond. That's why 1 into number of monodentate ligands. If there is bidentate ligand, one bidentate ligand makes 2 bonds now. That's why 2 into number of bidentate ligands. If it is tridentate, it will make 3 bonds now. So 1 like number of bidentate ligands into 3, because it is a tridentate. Like that you need to make a formula for this coordination number. Okay. So why I am explaining this formula also? Yes, if you learn this formula, it might useful for your EAP set preparation also. That is the only intention here. Then next, coordination entity. What do we mean by coordination entity in these? See, it is nothing but the square bracket you are using to indicate the complex. Right now, the part of the compound containing the central metal atom or ion bonded to the ligands enclosed in the square bracket. See, what are the things you are representing? See, you are writing a square bracket like this now. So whatever inside this square bracket, so this complete sphere, this square bracket, whatever the inside the things we have, completely all together considered as coordination sphere. What I am saying? Coordination sphere. So now for example, I am writing a complex here. Just see what I am writing. Cobalt NH3 6 times Cl3 I am writing. Outside the sphere, outside this bracket, square bracket, I am writing Cl3. So here I am writing Cl3. So now what is the coordination sphere here? You can say only the thing that is present inside this coordination sphere, inside this square bracket, is considered as coordination sphere. It means how many ligands you should say here? Only 6 ligands are attached with the central atom. Okay, coordination numbers of this central atom will be 6 in the complex. So these are not ligands, these are not comes into the coordination sphere. These are just normal ions only. Okay, therefore now what you can write? Part of the compound containing central atom or ion bonded to the ligand. See, part of this complex, part of this compound containing central atom or ion bonded to the ligands enclosed within the square bracket, within this square bracket is considered as coordination sphere. So now you can see here COCl3 NH3 tries. So this is a coordination sphere of the complex. So here you have 4. So what you can say? This is a part of this complex which is completely inside the square bracket now. Yes, you can say this completely as a coordination sphere. Okay, right. Is this clear? Guys, if this is clear, just click on the like button, and also you can share with your friends, those who are preparing for IPE exams. Okay. Then next, one more thing, if you observe, central atom or ion. So what do we mean by central atom or ion? So we are talking about this complexes now. So whatever the metal atom or ion you are seeing here, that will be considered as the central atom. The metal atom here you are seeing now, the metal atom or ion to which ligands are attached. So now what happens to this cobalt? There are 6 ammonia ligands attached right now. So what do we mean to say here? Cobalt is our central atom here. Okay. So how can you define the atom? It can be metal atom. Okay. The metal atom or ion to which ligands are joined or attached is considered as central atom or central ion. Okay. Yes, this is the basic thing you need to remember here. Okay. The next one here, If you observe this example, what you are seeing here, Namita Gowda, sir ये कौन सा बोर्ड का है? Yeah, so this is for intermediate board of examination for both Telangana and AP students. Okay, it is for Telangana and AP students. Okay, and it will be also useful whether if it is similar way, if your paper also, if you are out of these two states, out of these Telugu states, just check your syllabus. If it is similar to this, yes, you can also follow this. Right, now look at here. Next, here if you see this example, FeCN6 power, like if you see here -4 charge is there. So what do we mean by these? See, 6 ligands are there, 6 coordinate like cyanide ligands are attached to the central atom here, iron. So now what is the central atom here? Iron, that's it. Fe plus 2 is your central atom here. So the next one here, one more thing you need to know, one more new term I am adding here out of this discussion, that is oxidation state. So what do we mean by oxidation state? Oxidation number or oxidation state. So this is the charge, the net charge, the arbitrary charge that is present on the central metal atom when all these ligands are removed from that central metal atom. It means, for example, here I am writing, so FeCN6 4 minus we have right now. So now what is the coordination number for these? It is 6. You are saying like here number of ligands are there, by looking at that number you are saying it as a 6. Okay. Now if I ask what about its oxidation state of this iron, if I ask, consider it as X. What I am saying? Consider it as X. Okay. So now how many ligands are there? 6 ligands are there. Each ligand charge is -1. Now what is the overall charge present on it? -4 now on this bracket, on this square bracket, it is -4. So equals to -4. Now X becomes how much? -4. So this is -6. If you send this side, it will become +6 right now. So X will be now +2. So this is the oxidation state of central metal atom in this given complex. Okay. So for iron, what is the oxidation state you are seeing? +2. Okay, remember this. So this is the extra point I just wanted to add here. Yeah. So the next one here, if you observe homoleptic complex. So what do we mean by homoleptic complex? See, you have seen like this. What I told you that whatever the species present inside this square bracket, all together is considered as coordination sphere right now. So in this coordination sphere, along with our metal atom, along with our metal, let us say if the metal is cobalt, okay, so along with our metal, if the all the attached ligands here, whatever the ligands you are writing, like ammonia ligands I am writing here, so if all the attached ligands are same, then you can say this complex as coordination, like homoleptic complex. If sometimes it will be like this, cobalt, along with that there will be 3 ammonia ligands and there will be 3 chloride ions. It means what you are getting here, there are different type of ligands in this coordination sphere now. So if all ligands are same, you should say homoleptic complex. If they are not same, if all the ligands attached to the metal atom are not same, then you can say it as a heteroleptic complex. Okay, just listen here, a complex in which a metal ion is bonded to only one kind of ligands, yes, then you can say it as a homoleptic complex. See here, cobalt hexaamine complex we have. So it is a homoleptic only, now all ligands are same. Here also hexacyanoferrate complex is there. Yes, here also all cyanides are same. So all the ligands are same. So these are the examples of homoleptic complex. Okay, right. The next one here, heteroleptic complex. What do we mean by heteroleptic complex? A complex in which metal ion is bonded to different kind of ligands. See here, ammonia is one kind of ligand, next chloride is another kind of ligand. So it means if different kind of ligands are present, you just simply say it as a heteroleptic complex. See what I have mentioned here, CONH34 Cl2 plus. Okay, two different ligands are there, now two different type of ligands. Here also one is aqua, another one is chlorine. So it means this is also two different type of ligands now. Yes. So these are examples for heteroleptic complexes. Okay, right. Is this clear or not? Guys, if this is clear, just click on the like button, and if you have any doubts, please mention. All rounder in the chat box. Hello sir, hello dear. Yes, I hope you are following the session. is there any confusion in understanding these terms here? No, right? If there is anything, please mention. If not, just click on the like button. The next thing here is, what is stereoisomerism? Explain geometrical and geometrical isomerism in coordination compounds, giving suitable examples. This is one more question. Yes, before going to discuss this, I just want to add the previous question into our discussion first. So look at here, the question is from Werner's theory. What is that Werner's theory? Just look at here, the first question and most important question is, explain Werner's theory of coordination compounds. So what is Werner's theory? So just look at here, there are some postulates here. I hope you got to know how to calculate coordination number and oxidation state right now. So if you are clear with the calculating and identifying coordination number and oxidation state, yes, you can easily answer these Werner's theory based questions even in your NEET, JEE and EAP set exams also, along with your IPE preparation. See here, for example, I am writing here FeCN6, here I am writing minus 4, I am writing minus 4. Now just read here these points, then I will explain about the thing which I have written there. See, Werner's theory, what this Werner theory says is, in coordination compounds, metals show two types of valency. It means this metal atom here, iron metal atom is there now. So this will show two types of valency. Okay, so one is called primary valency, other one is called secondary valency. Okay, so primary valency is also ionizable valency. What it is? It is also considered as ionizable valency. And now when it comes to secondary valency, this is a non-ionizable valency, or you can say simply coordination valency. Okay, I will tell you everything very clearly, just follow my discussion for few more minutes. Okay, right. So simply remember, whenever they ask for primary valency, you just calculate the oxidation state of this central atom in the given complex. What is the oxidation state of this iron in the given complex you got? Previously we did now, consider it as X, there are 6 cyanide ions, so each one minus 1, overall charge is minus 4 on it, so X will be plus 2. So this is the oxidation state of iron. So you can say, what is the primary valency of iron? That is nothing but oxidation state. What is its oxidation state? Plus 2. So primary valency will be plus 2. And next, secondary valency or non-ionizable valency. It means this is nothing but coordination number of this complex. What is the coordination number of this complex? It is 6 now. So that is its secondary valency, and it cannot be ionizable. Okay, what I am saying, it cannot be ionizable, that is why I am saying non-ionizable. Or if you see here coordination valency, it means within this square bracket how many ligands are there? 6 now. So that is what its coordination number or coordination valency. Okay, so primary valency, secondary valency is clear now. So why I have given this explanation, this is useful for your JEE, NEET and EAP set exams. Now I will tell you how to present in your IPE exam, in your board exam for this particular question. So look at here. First of all, in coordination compounds there are two types of valencies. One is primary valency, other one is secondary valency, that is also called as non-ionizable valency. Now primary valencies are satisfied by negative ligands, whereas secondary valencies are satisfied by both neutral ligand as well as negative charged ligands. Okay, right. Next, each metal ion has a fixed number of secondary valencies called as its coordination number. What is that? Each metal ion has a fixed number of secondary valency called as its coordination number. Okay. Next, secondary valencies have definite spatial arrangement giving specific geometries. It means we just now discussed. For example, here if you observe this complex, here this complex if you observe, so there are two types of lines which I have indicated here. One is dotted line and one is straight thick line right now. So now this thick line indicates the coordination number. What is the coordination number here? You are seeing how many ligands are there with the thick line, with red color line now? 6 now. So now if you try to join them everything like this, you are going to get a octahedral complex. What type of ligands, what type of geometry you got? Octahedral geometry now. So just consider only this thick line, red color lines only. So if you observe that, we got a octahedral complex. It means this secondary valency showing ligands are properly oriented around the metal atom, and that is resulting to show a proper geometry for that particular complex right now. So that is nothing but coordination number only now. So how many red color lines are there? 1, 2, 3, 4, 5, 6. So coordination number is how much? 6. So this coordination number 6, it means you are writing this complex as CONH3 6 inside, and these dotted lines we have now here. So how many dotted lines are there? 3, with 3 chloride ions. You can write it like this. So now whatever present outside this coordination sphere are not considered as ligands now. So these chloride ions are not ligands. So whenever I place this in the water, in the aqueous medium, what happens? You are going to get your cobalt hexaamine complex, and these 3 chloride ions, okay. So like this it is getting ionized right now. So when it is getting ionized, now chloride ions are outside the coordination sphere, now came out of it right now. So now since it has negative charge, now what they will do, since cobalt is in +3 oxidation state, it means metal atom having some positive charge. That positive charge definitely attract the negatively charged species now. So that's why they have light or this ionic interactions like this, Now this this whatever the dotted lines are there now, those are ionizable, because when I place this in the aqueous medium, what they are becoming? They are becoming ions, they are getting separated now. That is why I can say these are ionizable valency. What I am saying? Those are ionizable valency, or you can simply call them as primary valency also. What is that? Primary valency also. Okay. Now just look at here what I am explaining here. See, secondary valencies have definite spatial arrangement giving specific geometry. Yes, in this complex you have seen coordination number 6, you got octahedral geometry. The next, so in this complex if you observe in this complex, now how the formula is written here. So the previously formula is written like this when I written this structure. So now I am modifying this same chemical formula into different manner. See, so I am just removing some ammonia ligands. So I am adding only 4 ammonia ligands inside. Okay, ammonia ligands are only 4. And 2 chloride ligands. Okay, outside the sphere I am writing 1 chloride ligand. Now how many ions can get ionized here? So how many things are getting ionized here? So only 1 chloride ion is coming out right now. So it means these chlorines which are present inside the coordination sphere will not get ionized. Okay, therefore they will satisfy no primary valency as well as the secondary valency, because these are also arranged in the octahedral manner along with the ammonia ligands. Okay, therefore you can see in this complex the primary valency is how much? Primary valency is only ionizable valency, only chloride ion is getting ionized now, and you can say primary valency properly comes from oxidation state. From where it comes? Oxidation state. So just find the oxidation state of this metal, and that will be written as a primary valency. Okay. Now when it comes to secondary valency, so that secondary valency comes from its coordination number. What is the coordination number you are seeing? This is 4, this is 2, total 6. Coordination number is how much? Total 6. If you find the oxidation state, you will get 3. That will be the primary valency in this complex. Okay, that's it. Hope the discussion is clear. Right. Next. Okay, those who are asking me. So now look at here. So what I am saying, primary valency is 3 and secondary valency is 6. Okay, it is satisfied by 6 ammonia ligands in this case. Okay, next. So if you change this formula, see, is there any ionizable valency? No ligand will comes out of this coordination sphere now when we place in the water. Therefore, so you can say the ionizable valency here we can only get from oxidation state, that is +3, there is no ions coming out. Okay, therefore it will not give any ions since there is no chloride ion coming out. If I treat this with AgNO3 solution, there will not be any AgCl kind of precipitation because there is no chloride ion outside. But here you have 3 chloride ion outside now. So if you treat this with AgNO3, what happens? You will get 3 AgCl precipitates. Okay, so that's what. Okay, right. So these are only ionizable which gives precipitate. Okay, with AgNO3. Next. So yeah, this is how you need to mention in your exam. Primary valency is 3 satisfied by 3 chloride ions. Secondary valency is 6 that is satisfied by 3 chloride and 3 ammonia ligands, because primary valence is satisfied only by negatively charged ligands. So how many negatively charged ligands are there? So 3 chloride ions are there now. So only this will be satisfying primary valency, and secondary valency, all these ligands will satisfy the secondary valency. That's it. Okay, right. Then next here, stereoisomerism. Okay, we need to understand this stereoisomerism. I will explain this, just listen. Now look at this, what they are saying, what is stereoisomerism? Explain geometrical isomerism in coordination compounds, giving suitable examples. So here, stereoisomerism is a form of isomerism where two compounds have same chemical formula. So they have same chemical formula, but the sequence of bonded atoms same chemical formula, and also the arrangement of atoms are also sequence of arrangement of bonds also same, but they differ in the spatial arrangement. It means very simple. Let me explain you this. Look at here what I am writing. So the chemical formulas will be same. For example, you can see here platinum. Here I am writing Cl, Cl, NH3, NH3. Now what is the formula I have used here? Platinum, 2 chloride ligands and 2 ammonia ligands. Right now it is a tetra coordinate complex, like this I am writing. So now this formula can be written in this manner, and you just see here what I am writing. Platinum, here ammonia ligand, and here ammonia ligand, and here chloride, here chloride. See, both complexes have same chemical formula, right? So both complexes have same chemical formula, but how do they differ? They have same chemical formula, same bond connectivity also same, but the arrangemental, the spatial arrangement of atoms is differ here. So these are cis to each other. See, it means 2 chlorine atoms are side to each other, okay, and here 2 chlorines are anti to each other. It means here this is a square planar complex. What I am saying, it's a square planar. It means just like a square, you just imagine you have a square, at the center of that square you have platinum, at all the corners of the square we have ligands. Okay, so now what is the angle between the two corners with respect to the central atom here in a square? It will be 90 degrees, no? Yes. If same groups are arranged at 90 degrees to each other, then you can say it as a cis isomer. What you can say? It is a cis isomer. Okay. If the same groups are attached at 180 degrees to each other, what I am saying, 180 degrees to each other, you can say it as a trans isomer. Okay. Now you got to know about cis and trans. Cis isomers are 90 degrees to each other, whereas trans isomers are arranged, ligands are arranged 180 degrees to each other. Same ligands are at 180 degrees to each other. Okay. Hope this is clear. Now just read this once again. So stereoisomerism is a form of isomerism where two compounds have same chemical formula and sequence of bonded atom, but differ in the spatial arrangement of atoms or ligands. Yes, the spatial arrangement of ligands is different now. Here they are 90 degrees to each other, same ligands are at 90 degrees, and here same ligands are at 180 degrees to each other. So one is called cis, the other one is called trans. Okay, if they are opposite you can say anti or trans. Okay, so it is a type of stereoisomerism observed in heteroleptic complex, where it is observed only in heteroleptic complex. See, there are two different type of ligands now, so we can say it as a heteroleptic complex. So this geometrical isomerism observed in heteroleptic complexes, okay, due to different possible spatial arrangement of ligands around the central atom. Yes, due to different possible arrangement of central atoms we are getting these two isomers now. Yes, okay, it is possible in heteroleptic complex, and that ligands when we are arranging should give a new isomer to a new structure, like new arrangement of atoms which are differ in their spatial arrangement. That's it. Okay. So now cis isomers occurs when two identical groups occupy adjacent at 90 degrees to each other. Yes, this first discussion. Okay. Now trans isomers occur when two identical ligands occupy opposite position, that is 180 degrees to each other. That's it. So you got cis and you got trans. The next one here, if you see octahedral complex. Okay, if coordination number is 6, you are going to get octahedral complex, and if coordination number is 4, then you are going to get a square planar complex. Okay, you are also going to get tetrahedral in coordination number 4, but in tetrahedral there is no geometrical arrangement. Okay, so it means octahedral and square planar complexes are showing this geometrical arrangement. What are the things? Square planar and octahedral. So you might be getting that why tetrahedral is not having geometrical isomerism, means it is not a planar molecule first of all. Okay, right. So now look at here, this is a cis isomer we discussed, this is a trans isomer. For I can say tetra coordinated complexes. Okay, so in tetra coordinated complex it is a square planar, platinum complexes are square planar, and which is a heterolyptic. See, two chlorides, same ligands, two ammonias, different ligands which are cis to each other. See, 90 degrees to each other, same ligands are at 90 degrees to each other, so you can say cis. Okay, same ligands are 180 degrees to each other, so you can say it is a trans isomer. Now next we have octahedral complex. What I am saying, we have a octahedral complex. In this octahedral complex, again if the same ligands are at 90 degrees to each other, you can say it is a cis isomer. If they are 180 degrees to each other, you can say trans isomer. See here in the first structure, this is octahedral now. So octahedral structure, if you imagine how it will be, there will be a square, on the square planar thing, like you got a square here, and on this square, if you consider this as a square, and above we have one ligand and below we have one other ligand. So chloride ion above one, below one. How these chloride ions are attached now? They are at 180 degrees now, like a straight chain, so straight line. So it means what is the angle between these two things, two ligands here? So here one chlorine, here one. So it is 180 degrees now. So if they are 180 degrees, same ligands are at 180 degrees. What you can call it as trans isomer. What you can say? Trans isomer. Okay. Now what about this ligand? See here to this square, now one ligand is attached here and one more ligand is attached here. Now what is the angle between this square, this ligand present in the square planar, and this above ligand or below ligand? They are 180, like this, the one which is in the planar and one which is above this plane. So what is the angle between this plane and this one? This is just 90 degrees now, up to from here to here, something like this, something like this. This is a line, one is above, one below, and I am placing this square here. So now what happens between these two? What is the angle you are having? So it will be only 90. So here the chlorine atom here and chlorine atom here are arranged with 90 degrees to each other. So 90 degrees means what you can say? It is a 90 degrees means it is a cis isomer. Yes, you got cis isomer, you got trans isomer. You just mention this type of example in your exam, therefore you will definitely get full marks. Okay. So what is the ligand formula I am giving here for this? Cobalt NH4 NH3 4 times Cl2. Okay, that's it. This is the ligand you mentioned. It has two possibilities. You will get cis isomer with respect to two chlorines 90 degrees to each other, and if you place two chlorines 180 degrees, you will get a trans isomer. That's it. These are the two indications you need to mention in the exam. That's it. You will get good marks. Okay. Then next, sir, which class is this? So this is an IPE class for second year students, those who are preparing for intermediate board exams. In both Telangana and AP students, AP states, these sessions are helpful. Okay, right. Which class is this? I hope your question got the answer for you. The next. So there are the other things here. See, they will give 4 or 5 compounds like this, and they will ask us to write the formulas. See, using IUPAC norms, what they are saying, using IUPAC norms, write the formulas of the following. Okay. So how do you write these? See guys, same questions you can also see in your JEE and NEET EAP set also. Okay, do not worry, like if you haven't prepared previously for your JEE, NEET or EAP set exams, do not worry. Now you make your preparation in a productive manner. Do not by heart the things, try to understand the concept. Okay, listen to these classes here we are discussing, and later you just practice on it. So once after doing this, if you have time along with your IPE preparation, just see 1 or 2 EAP set questions also if you are preparing for MSET. Okay, if not now, at least after the exam you just continue your preparation for EAP set. After your board exam, at least you focus on your EAP set without neglecting it. Okay, right, look at here what they are saying, tetrahydroxido zincate to ion. So it means what? Tetrahydroxido. So tetrahydroxido, tetra means 4, hydroxido means hydroxide ions like OH minus ions. How many they are saying? OH minus ions are 4. Okay, OH minus ions are 4, so 4. So they are saying zincate, it means zinc. Okay, now close the bracket. Okay, so zincate 2, and they are saying ion. So this complex is an ionic complex. So here what is the oxidation state they mentioned? 2. So each OH minus ion is minus 2 charge. So zinc should be plus 2 oxidation state, and remaining minus 2 will be mentioned here, that's it. So this is the structure of tetrahydroxido zincate 2 complex. Okay, now all these questions are previous year questions only. So since it is an IPE, yes, mostly questions will be repeated from our discussion only, because yeah, if you look at the past papers, how they are, every time same question comes. I mean, there will be some questions from each chapter, only those questions will be repeated. Now from coordination compounds, whatever we discussing till now, from those only we can expect a question. Okay, right. Okay, but try to learn these, writing the structures of the complexes, looking at these names. Okay, so that even they ask a new question making with a new compound, yes, you can easily write by following the rules. Okay. Now look at this second question here, what they are saying, potassium tetrachloridopalladate. So it means palladate means whenever they are ending the name with 8 like this, it means there will be negatively either if they mention it as ion, there should be negatively charged ion. Okay, otherwise our coordination sphere should be in anionic position when they mention the name with 8 at the end for the metal atom. Okay, for the metal atom, if they are mentioning it as 8, so if you write sodium chloride, first you are writing sodium cation, then next you are writing anion. So whenever they say palladate, zincate like this, the complex should be in the anionic position, in this chloride ion position. Now here if you observe, potassium is there, yes, I am writing potassium. Okay, after that tetrachlorido, it means there are 4 chlorine atoms, Cl4. Okay, and palladate, it means Pd. Okay, Pd. Now what they are saying, palladium has 2 charge, oxidation state is 2. So if it is 2, so how many potassium should be there? So you should keep 2 potassiums. So K2 Pd Cl4. So K2 Pd Cl4. This is the formula of this potassium tetrachloridopalladate 2 complex formula. Okay, this is also clear now? Yes guys. Now next, what is the compound name they have mentioned? Hexaamine cobalt 3 sulfate. It is also easy, just follow me. So here hexaamine, so mentioned NH3s are 6 hexaamine. So cobalt, so here you should mention cobalt like this. Okay, cobalt, okay, cobalt, hexaamine cobalt 3 sulfate. So 3 sulfate. So it means if I write only one sulfate, how it will be? Sulfate ion will be minus 2 charge. So therefore complex will be plus 2. So cobalt will get only plus 2 charge. But they specifically mention oxidation state is 3 now. So what to do here? So I am multiplying this number with 3. The sulfate is there. So I am multiplying this number with minus 2 means 3. So it becomes minus 6. So I want here 2 now, so I am writing here 2. So hexaamine cobalt 3 complex with the oxidation state 3, that's why To satisfy that, we are writing these numbers here 2 and 3. This is how you need to mention the compound. The next one here we have is potassium trioxalato. It means, I will tell you potassium first, okay, potassium. Next trioxalato. So trioxalato, oxalato means OX is a symbol, tri, it means actually it should be tri, okay, tri here I have mentioned. Chromate, chromate means chromium, okay, each oxalate is -2, it is a bidentate ligand, -2, how many ligands are there like that? 3 are there, okay, it means -6 charge we will be getting here, but I want chromium +3, it means you can put 3 potassiums, the next 3 chromiums, chromium with the +3, okay, so K3 Cr OX means ox, C2O4 thrice, that's it, this is the indication of the formula, okay. Next here if you observe hexaamine platinum 4 ion, okay, so it means platinum hexaamine, amines are how many? 6, hexaamine, okay. Now ion, name is ending with ion and charge with a +4, oxidation state is +4. Since ammonia ligands are neutral, you just mention here +4 charge, that's it, this is a symbol of the given complex, okay. How easy it is, see Pt NH6 4 place, okay. And the next complex here is pentaamine nitrito N cobalt ion, it means how many amines are there here in the square bracket, there is cobalt and pentaamine, it means 5 ammonia ligands are there, and along with this nitrito NO2 like this, okay, nitrito NO2 ligand is there, okay, like this we have, okay. Now what they are mentioned, charge is +3 and it is an ion, so it means there is some charge over here, okay. So ammonia ligands are neutral, so oxidation state with respect to ammonia is 0, so X, and nitrate ion is -1 charge, and I want to get this charge here, that is Y. Now what is the oxidation state they mentioned here? 3 now, so our X value is 3, so here mentioned X value is 3, so 3 minus 1 is +2, right, Y is equals to +2, it means what is the charge here, you need to indicate +2, that's it, +2, that's it, this is the complex you got. Hope the discussion is clear. Guys, if it is clear, just mention clear in the chat box. One more question here we have. Now this time it is reverse. By giving the formulas, they are asking names. Again, it is also very easy, guys. These are 4 marks questions, like you can easily get by understanding them. And these are some student tips we have mentioned in our modules, okay. So now you can access these booklets from our MedWorld app. Download from Play Store MedWorld app and just say hi in the chat box. So our team will send you the modules, okay. So do not worry about that, it's free of cost, you can access them through this MedWorld app, okay. Next, look at here, this is the complex they have mentioned and they are asking IUPAC name. So now when I say NaCl, how do you write the name? First sodium, next chloride, now. So here also first write the species which is present in the cationic position, next anionic position. So what is the cationic position here? See, there are amines, ammonia ligands are there now, how many are there? 4. Next water, you should call water as a aqua. The next chlorine, you should call chlorine as a chloride, okay. So it means ammonia, A comes first now, so AM comes first, then next AQ, aqua, then next C, chloride, okay. So it means how many ammonias are there? 4. So you can say tetraamine, what I am saying, tetraamine, okay. Next, how many aqua molecules? Only one, tetraamine aqua. Next, this one chlorido, what you can say, chloro or chlorido, okay. Next, cobalt, next metal only remaining in this square bracket, cobalt. What is the oxidation state of cobalt? If you calculate here, you will get +3, cobalt 3. Then next, what is this? The coordination, out of this coordination sphere, we have anionic position, that is chloride. It means you need to leave some space between the complex name and this ionic sphere, anionic sphere name, chloride. So tetraamine aqua chloro or chlorido cobalt 3 space chloride, that is a proper way of writing the name, okay. Then next one here you have carbonyl ligands, how many are there? 4 with the nickel complex. Okay, so tetracarbonyl, what I am saying tetracarbonyl nickel, what I am saying tetracarbonyl nickel, what is the oxidation state? Carbonyl is a neutral ligand, so oxidation charge with respect to carbonyl is 0. Okay, therefore there is no charge here, so oxidation state of nickel here is 0. So you can see here tetracarbonyl nickel 0. Okay, right, you need to indicate oxidation state in this parenthesis. Okay, then next here if you observe, this is a complex K3FeCN6. Okay, very easy. First write cationic sphere ion name. First here it is potassium. So just mention potassium, no need of mentioning 3 potassium like that. Okay, just mention potassium. Then next after these 2 spheres, between these 2 spheres you need to leave some space. Potassium space. Now ligand's name first, hexacyano. Then next ferrate 2, ferrate 3 here, ferrate 3. So potassium, hexacyano, ferrate 3. So how you got this 3? So 3 you got because its oxidation state, iron oxidation state here is 3. And why I am mentioning it as ferrate, why not iron? Because our ligand in which position it is in anionic sphere now, so that's why it is ferrate. If it is in cationic position you should call it as iron only, but here it is in anionic position, that's why we are saying it as ferrate 3. Okay, right. Next, what about this ligand, like complex name? Here you have triamine, the next triaqua, chromium 3 space chloride. See, triamine, triaqua, chromium 3 chloride. That's it. So these are the things you need to get from this chapter. Okay, and you know guys, in the next class, these are extra points I just wanted to add for you to make you more clear with this. Okay, so in the next class I will be discussing the other remaining SAQ questions from P block, from solid state, and also from and also from metallurgy. Okay, and then next organic. All these things are we have to be discussed. So this will be discussed in the upcoming session. So now what you need to do, if you are new to this channel, just click on the subscribe button and you can share your feedback in the chat box. Okay, and if you are expecting any specific topic from our side, you can just mention in the chat box. We will be making them in the upcoming sessions. Okay, so thanks for watching, stay connected, and you can share with your friends. Thank you.